Hi, welcome to this video where we're going to be talking about mastering semantic models in Power BI. So first of all, what is a semantic model? A semantic model in Power BI represents. Hi, welcome to this video where we're going to be talking about mastering semantic models in Power BI. We're going to be understanding what a semantic model is, the design, and how to deliver data insights with semantic model in Power BI. Now, what's a semantic model? A semantic model in Power BI transforms raw data into meaningful business-friendly information. It defines relationship, measures, hierarchies, and metadata, making complex data accessible. So some of the key attributes of semantic model is it abstracts complexities, it simplifies data for end users, enables reusability, facilitates scalable analytics across various reports and dashboards, and it drives insights with Power BI and other analytics tools as well. Now, what are the core components of your semantic model? It includes your tables and relationships, your calculated columns and measures, your hierarchies, and your metadata as well. Now, why do semantic models matter? They are useful in implementing robust analytic and scalable business intelligence. They ensure consistent reporting across the organization, improve data accuracy and reliability, empowers users to create their own report confidently, and leverage Power BI data set or Fabric for broader applicability. Now, there's one key concept we need to know to be able to carry out semantic model in Power BI, and that is the concept of data modeling and dimensional modeling. Now, you see a lot of these words used in a lot of places, and sometimes they tend to be used interchangeably, but there's a slight difference. Now, slight difference between the two. In Power BI, we do more of dimensional modeling in Power BI than your traditional data modeling. And I'll just be highlighting some of the key differences. So data modeling focuses more on the structure and integrity of data, while dimensional modeling is focused on analytics efficiency. So you're basically preparing data to be efficient for read purpose in the sense of reading data, while data modeling focuses on you preparing data to be able to be loaded for right purposes. Now, typical use case scenario is you have your OLTP, that's your online transactional processes, and so those are like your day-to-day processes which every organization engage in. Um, probably your bank sector when somebody makes a transaction in the POS, the data keeps sent to a database as well. Now, for dimensional modeling, it focuses on OLAP. That's your online analytic process. And the key thing is this allows you to analyze historical data. So it doesn't focus mainly on writing data, it focuses on reading large data in comparison to a particular period of time. Now, for the structure of data modeling typically shows your ERD diagram. This represents entity relationship diagram. It shows how different tables in a database are connected together using specific keys as well. And data model is highly normalized. So because the key focus for data modeling is writing a data, writing data. Dimensional model, on the other hand, tries to focus on how easy to read data, and it focuses on your star and your snowflake schema. For Power BI usage, is the preferred semantic layer. That's the dimensional model. Now, when we are talking about schema type, and like I said, for Power BI, we mainly do dimensional model. We consider the star schema to be your preferred choice of schema for data for dimensional modeling with Power BI. And what do the star schema entail? You have one central fact data, and you have dimensions linking to the facts data. For Snowflake schema, on the other hand, you have dimension tables are further normalized into sub-dimensions. So, for example, you have a product table, it can further be broken down to product category, product subcategories, and this is more complex so more complex joins. So you have to be joining different tables together based on keys, and it's useful for highly normalized data sources, but less common in Power BI. So it's not normally the preferred route for Power BI, but it's also part of the options. Now, what are the key terminologies you need to know for semantic models in Power BI? You have your fact table. Your fact table is the central table with measurable numerical data. So your fact table typically contains your IDs, which points to which serves as keys to other tables, and your value field. So your fact table are typically quantitative data, include quantitative data which you can aggregate and provide meaning. While your dimension tables, they provide descriptive information about the business entity. So if I state 5 million was made, I'm sure the question you may ask is, okay, where was that 5 million raised? Who made that 5 million? Is it a customer? Is it their business? When was it made? So dimension tables provide further context based on your facts. So beyond just the values which you have, it tells you more details, more granularity about what happened. And the key concept for dimension tables is follows the you can think of it as answering your W question, the who did what, when, and why. Then you have DAX. DAX represent data analysis expression. For this video, we won't be covering that yet, but probably in subsequent videos, we can share that as well. You have your measures, which are dynamic aggregation logic calculated on the fly in visuals. You have hierarchies, which talks about predefined path for drilling down into data. And you have role level security, so restrict data visibility based on user rules. So what this entails is that rather than sharing your reports in organization, not everybody should have access to see the same level of data. So you should be able to set security which allows people to be able to see what they are meant to see, not beyond what they are meant to see. So how can we go ahead to build semantic models in Power BI? First of all, you connect and transform your data, design relationship, create measures with DAX, add hierarchies, test, validate, and publish. Now, without wasting much of our time, we have this simple data set which we are going to discuss and apply some bit of dimensional modeling into this. Now, in typical organizations, data comes from somewhere, and data could either be organizations that have a well-structured, probably database or database system, or data could come from different tables. Data could come from different tables. You also have organizations which they don't exactly have the right structure put in place. So data could probably come in as a single transactional file, which is like in this particular instance. Data coming in separate tables, you knowing the keys, you can easily be able to deduce or identify your facts, your dimensions, and probably go ahead to create um your tables from there. But I'm just going to talk quickly on this. And this is a scenario where you have people probably coming from Excel background, which typically, when they get this data, the first thing they think of, okay, let me go ahead to analyze the data. And this works. This works. Analyzing the data this way works directly. But the key question you need to ask yourself when you're doing any report is, how reusable is this report? Also, if more input, if more granularity needs to be gotten from the data, will this report perform in an optimal level? Will I always have to be introducing redundancies to my data? So let me give a typical example. Now, if I ask what's the revenue for the full models that we have, with this data currently now, we'll be able to generate this report. Now, let me give an instance now. We provided that report of the revenue and the models that we have. Now, managers now says, okay, these are models represent a particular name. I want to be able to get, and let me just quickly do some bit of Excel, Excel, and I'll play. So I'm just gonna do this data, remove duplicates. We have this, then we have, let me call this. So we have model, then let's go with model name. Now, all these models, apparently, they are probably names of cars or something. So I'm just going to be keeping some random cars that come to my head. Maybe may not be right spelling. Don't judge me too much. But just keep it. Some of those that come to my head. Probably these are the name of cars. Now we want to see what is the revenue for these cars for the for these cars. Now, based on this data which we have here, for people coming from an Excel background, what they would typically do is probably come here, give a model name, and they'll go ahead to join the table using probably your X lookup or your V lookup, which could work. And yes, for those who are more experienced in Excel, and you think, okay, you doing that, if it's a one-time task, it works. But what if it now comes forward again and they ask, okay, beyond the model name, we want to see uh model dates. So they come to this data, they probably do created on, so when the models was actually created, there's now another data for model created on. Now, what you will have to do to be able to get this bit of information is you have to be introducing all those columns every single time to this data. In turn, increasing the size of the model and also reducing the performance of the model, increasing the size of the model, and also introducing a lot of redundancies. That's repetition of the same piece of information over and over again. Now, what data modeling is saying essentially and is the ability to connect two or more tables together based on relationship that exists between them. So rather than going ahead to do model name and all this and doing your VLOOKUP, what the data model will do is it establishes that there's a relationship, a column that contains distinct attributes, which is this model here. I will be able to connect it to this particular data based, so there will now be a relationship that is established between those two tables. And in essence, this table, the descriptive attribute of this data can keep on increasing, but I don't have to introduce it into this this particular table. So that's like the beauty and the some of benefit of data model. Like we can also consider that for trade dates, for the date period as well. Now, how can you go ahead to build a simple data model when you have one single flat transactional file? What I'm going to do is I'm going to copy the headings and come to this sheet one. And let's do Control Alt V, value transpose. Yeah. So I have these values here, right here on my screen. Now, the first key step which I will state is, first of all, we need to know what will be our dimensions and what will be our facts. I said your dimensions normally answer the four W's, either of the four W's. So like what your dimension table contains, while your fact contains IDs and contains value fields. Also, in your dimensions, your IDs must be unique. That must not contain duplicate. I'm just now the fact it can contain duplicates. So how do we identify the dimensions first? So the first thing to do is the quick key step is identify fields that relate to each other. Now this is a process which has been largely helpful for me when you have a single transactional file on how best to model it. Identify fields that relate to each other. And in this instance, looking at this data, for one, I can see region, market store. And this store is still talking about the location of the store. Region is talking about a particular location. This market is also talking about a particular location. So it's safe to say that I can group these three into a single table and call it DL, which is like team location. Location. Now the same for, let's check what other fields can we group together. Trade date is talking about dates. Physical period is talking about date. Day category is talking about a date. So it's answering the when question. So I can group this into DD, that's dim date, DD, DD, right? Now, model and line of business, because they are not really talking about, they are not really related with other categories, we can still have them as DM, this the model, and we can have this as DLOB, so they stand on their own. Now, this revenue and units sold will be value. They are just values, they are not dimensions. They are not dimensions. So first, group related fields. Now, after you group related fields based on business logic and all, the next thing is you need to identify keys, your keys column, your primary keys in your data. So how I'll describe it is the column with the least bit of granularity in your data. So to explain further is out of these three columns, and people who are watching this video from probably Nigeria, or if you have a general sense of locations in the world as well. Now, if I know this region, this North Central region, if I only had this data, now for some reason I didn't have this other data, with this data, would I be able to generate to know the particular market? Maybe I can predict the particular market. Maybe I can guess, oh, it's not central, so maybe it's most likely federal capital territory. Maybe. But will I be able to know the store? There are lots of other locations under the federal capital territory. So this North Central here is not the column with the least bit of granularity. What do I mean by this is the column that can help us easily identify other values or other columns in the data. The column that has the most granular, the least bit of information. Now, the same goes for this market. If I know this market, probably I know the region, but I don't know what particular store this market is in. But if I know this store, which is Abaji, now even with a quick Google search, check for Abaji. It should from knowing this store, I can know okay, Abaji is in Federal Capital Territory, and since Abaji is in Federal Capital Territory, it is in North Central, North Central. So in terms of granularity, that's like the flow chart. Me knowing this store, I will be able to identify the market and the region by knowing the store because it's the least bit of information. So even if probably these data were not included in the table, but by knowing this store, I will be able to populate this other data. But the same cannot be said the other way around. So with that example said, I can come here and I can call this K1, which is the first key, the first key. Now for the trade dates, trade for the date, I'm going to select trade date, physical period, and day category. Now with that same logic, day category is talking about what point of day is it? Is it a work day? Is it a public holiday? Is it a weekday? That's what day category is talking about. Physical period for specific organization. This can include they have different physical years, and physical time periods. So this can be a calculation which generates like okay, from April is the start of our year, so it's the first physical period, April to June, first physical period, and it goes on like that. Now, trade date is talking about the date the trade was made. Now, for this thing, using that same logic which we use for the other one, by knowing the date category, I wouldn't be able to tell what physical period it is. Uh, Also, by knowing the physical period, I can only guess, okay, since it's the first, based on my business understanding, this is showing 2015 01, I can guess probably it's talking about April. So April falls under the the physical period, but I will only be able to guess what physical period it is. But you see this trade date, very, very key, very, very vital in the sense of by knowing this trade dates, I will be able to know based on the business logic what physical period it falls under. April falls under 2015. So I could probably do a calculation. And based on these dates, 1st April 2014, I'll be able to know, oh, that's most likely maybe a Monday, Tuesday, Wednesday, Thursday, or Friday. So I know it's a work day. So these trade dates provide the least bit of granularity. So it's also a key here, which helps us to identify our column. So it's our primary key in this data. Now, as we go on a bit, don't want to complicate things a bit, but you also hear the general concept of surrogate keys, which makes things better. But we're going to build this model strictly using the primary keys as well to make things simple for people to understand. Now, that is for that. Now, for model and line of business, this would also be their own keys, K3 and K4 respectively. So once we've done that, we've identified our keys and we've identified our values. So what will our facts contain? Our facts, remember I said our fact contains our IDs or our keys and it contains our values. So I'm going to call this fact, 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 fact. So all of this will be inside our fact table, and all these DL will be our dimensions. All these DM will be our dimension table. Our dimension table at the end of the day. So how can we go ahead to do this in Power BI? Very, very simple. Probably the easiest thing which you do. I'm just going to save this. So let's go jump into Power BI. and see how that's done. So I'm just going to start with get data, specify Excel workbook because the data is in an Excel file. After I've selected Excel workbook, I'm just going to select what particular workbook the data is located in. And that should be sales. To make this easier, let me just find the file path. It's file, function info. Just going to copy the paths to get data Excel workbook. So let me just come to my PC and just try to paste the path. Okay, cyber issue. I'm just trying to see the path. Documents. Okay, it's just probably for. Okay, there's the data. I'm just going to select this and click on open. That's going to take me to Power Query where I can just do some simple, quick, and fast transformation. Okay, so I'm going to select this fact sales data. Remember in a previous, I said if your data is in a table, bet you go to connect to the table directly rather than the sheet data is in the table. So I can just select the table and I click on transform data. So this will open the Power Query editor interface for us, which we can go ahead to start doing some nice and interesting transformation. Yeah, so the data is largely clean, but we need to do some bit of transformation. So what I'm going to do is I'm going to right click and I'm going to duplicate this into, you need like 4 queries, 4 or 5. I'm going to duplicate this into like 5 different queries. And let me go for, so 3 more queries. I think one more. Yeah. So this first one, this fact two, I'm going to come to choose columns, and this is going to be our first dimension, which is our location dimension. So I'm going to choose columns. I am going to just select the region, market, and store, and I'm going to click on OK. So that will remove all other columns. Now this store, remember I said your IDs for your dimension table have to be unique. That's your IDs or your primary keys. Your dimension table has to be unique. So under this value, I'm just going to right click and do remove duplicates. So we have the unique stores like this, and I can call this dim. Dim short form for dimension. I can call this dim location. So see how fast and easy that was to create the first table. Now for the second one, we need the date. So I'm going to click on choose column, choose columns. I'm going to select trade dates, physical period, and day category. Click on OK. Now this trade date, remember, is a unique column. You need to remove duplicates from trade dates. So I can call this calendar, dim calendar or dim date. Dim calendar. And just dim calendar. Now this last two will be the model. You can just do choose column. Now you may ask, oh, why don't we leave model on it? Model with the fact. The thing is, if model is always going to remain one, that's fine. But like the example I showed, it may come a situation where you want to add model name, model creation date, model this. So having model as a separate table is always very useful. So I'm just going to remove duplicate from this. So the model, and the last one is going to be line of business. So the same logic applies to line of business. Just column. And I'm going to remove duplicate, right click and remove duplicate. Now we can go ahead to add index columns, which will just serve like, I can add index column from one, and this will like serve as a, if you want to create like surrogate keys. I'm just showing us how we can do that. We don't need it for our fact now, but just showing us this entire logic. So call it dim LOPs. So surrogate keys are very important because So sometimes not always good to trust like solely your natural keys because natural keys can change based on there's also a concept for people. There's also a concept called slow changing dimension. And surrogate keys best work to address some of those issues. For this D model, we can add an index column. And what this index column will do is, like I said, just going to be your keys. So instead of having the model, I can call this model ID, for example. Let me just come to this, call this LOB ID. So even for the location, we can, based on the store, we can create an index column. And I'm going to call this store ID. Now, how do we create our facts? Our fact contains our keys and our value. Now, I just want to show us for the sake, I'm going to duplicate this one more time. Now, if you want to just do it without using the surrogate keys which we created, how I'll go about doing this is I'm going to come from this home, choose columns, and I'm just going to select the primary keys and the date, the primary keys and the value. So I'm just going to select store, trade date, um, model, line of business, revenue, and unit sold. And this will be our facts. I don't need to remove duplicates for the facts. I don't need to remove duplicate for the fact. Now, if I want to use the surrogate kits, for example, to prepare this artifact. This artifact is based on our natural keys. Natural keys are these natural occurring keys, which is your natural primary keys, which are these values which we have here. But if we want to do it based on those index that we created, so let's take, for example, the name of a particular location has changed from maybe instead of Apache, maybe for some reason, it's not common, but maybe for some reason, this Apache state changed name. How can you keep track of the change? And that's what slow changes dimension talks about. And your surrogate keys help you keep track of that. So if you had to do it based on those keys, those IDs that we created, how we go about doing it is now after we've selected those columns, right? What we will do instead is I can delete this, for example. Just want to show us. Now this is the facts. After we've selected this, I'm just going to duplicate this. Now we can begin to do a merge query and now leave just the ID. So under this home, I can probably do merge queries. I'm going to merge it with the let's say DLOB. And what am I going to merge? Line of business with line of business. So if you see this, this is the join it's doing. So it's talking about joins. Yeah, I shared a video before. This speaks more about joins. So I'm going to select this and just select LOB. So this has those IDs that we created for the line of business. So at the end of the day, we can get rid of this line of business. I'm just showing us how that would look like. So we'll still do the merge queries for again, maybe net queries, and I'm going to do for model location, select store, next store, click on OK, then click on this drop down to expand it a bit and deselect all and just select store. So select store ID. Right? Now, I think, did we do for calendar? We can do based on this trade dates, add columns, but you can technically still leave trade dates. So, no really real needs for that. Let's see. Which I don't want to have the LOP, the store, then the model. So I'll just do the last one for model and show how that will be. To merge queries, click on OK, then click on this expand button to select model ID. What the merge column is doing it is joining the data based on the particular column that they have in common. Now, once I've joined this column data where I have the surrogate keys as the IDs, I don't need to have all this model line of business store in the data. So I'm just going to come to this choose columns and get rid of choose column. So it's always best to do your dimension like first if you can, so that you wouldn't even need to do choose columns more than one. So at the end of the day, you'd have just got rid of the other stuff. So I'm just going to deselect store model line of business, still leave revenue unit sold on this. So trade dates. I'm just going to come here, LOB ID. Now, I'm just doing this for the sake of showing us as well. The first method also works, like it works, especially if you don't have a really complex use case scenario, you can just go ahead to use the key, the primary key. So this store ID and this model ID. So let's see what happens once we close and load this. So I'll call this um, sales new. So after you are done with this your process, you can come to Power BI and can click on close and apply, and you close and apply the changes back to Power BI. And that should supposed to apply automatically, but if it's not, you can okay. It's loading. Can always click on the apply button. Now, once this data loading, it will create a relationship for us. Power BI will automatically try to detect the relationship based on our data. So see, data is loaded into Power BI. So let's see how that looks like on the model view of Power BI. So now that once you've created your relationship, now you can see under the model view, now ignore this other sales new. You have a star schema typically. So you have your facts, your dim location, line of business, your location, your model. So the reason why it's also called the star schema is also has like a star-like shape. Now this sales new, we can probably push it somewhere. The point of this sales new is I wanted to show us how this can connect to the other stuff. So we can connect this to trade data as well. Now connecting it to trade data, you can see there's something called cardinality. And under this cardinality, specify the type of relationship with in Power BI. And this is something very important for us to know. Creating relationship is very simple. Understanding the types are key. By default, the type Power BI typically wants to work with or prefer to work with is one to many, and that's your star schema like approach. So one one information in your dimension table is related to many occurrence in your fact table. That's why you said your keys in your dimension should be always unique. So your dimension table contains your descriptive attributes. So definitely there's a trade date and it's telling you that trade date is a work day and it's telling you the physical period. So there is only one trade date in your dimension table. But in your facts, somebody could have come to make a lot of orders or a lot of purchase in that particular trade date. So that's your fact data can contain many records, but your dimension should only contain one record. So that's one to many. One to one. Now, this in this scenario is that you're saying like literally is not really that useful, but there are some use case scenario, but you're saying that one data, both tables are unique. That is, one data is connected to one data, that there are no duplicates in either of the tables. Many to one is also like one to many. I would advise you to also take Microsoft documentation to read more about that, but it's also like it depends on where the direction of the relationship is going. So many to one. So if it's starting from your fact, going to your dimension is many to one. But if you're starting from your dimension, going to your fact is one to many as well. Now, many to many is the one that is not advisable in Power BI. That introduce redundancy. Power BI will even advise you again. What you are saying is that many dates, like you are saying this Tuesday, April, whatever, is not unique. So in case of many dates is related to many dates in a table, and Power BI do not understand this relationship. And that's why in some case scenario and as you progress, you get concept of bridge tables, which enable you to solve this many to many problem. But this is a simple relationship, one to many, one record in this dim calendar, as the dim calendar contains unique record is related to one record, to many occurrence on this fact cell. Now, the other thing to note is this cross filter direction. Single is the default and it's really, really best is at single. What both is saying is depends on your use case now, but what both is saying, you're saying this should also filter your dimension. And in an ideal scenario, you want your dimension because it's talking about descriptive attributes to be able to filter your facts, not vice versa. Now, let me show before I click on connect. Also, this make this relationship active is key. So beyond what you're doing is also essential. You make sure this is turned on, make it active. So if I don't do that, if I want to see a simple report of maybe day category and revenue, how I can come to this is day category under the dim, just select the check mark and to revenue. Let me just show this as a table. And you see all the values are the same because Power BI do not understand. There's no relationship that exists between those values. So what Power BI is doing is getting the sum of the values and applying it to all the rows. It doesn't understand the context. So here's the advantage of that modeling. Now we've done something like this. All we just need to do is move this trade date to this trade date. I'm going to click on save, make this relationship active, save. Now, once we are done with this, we can go to the report and we see that the values will be showing the accurate values for all those particular one. So this is still saving, this still saving. Yeah. Now once this is done, I can come to my report view and can see the values updated. So it's showing the actual values based on that. Now, one key thing to do, and especially for calculation purposes, when you have a date table, it's important you select it and when you have a date table, it's important you also try to ensure that it's probably analyzes it as a proper date table in the order. So I can come to this dim calendar and ensure I mark it as a date table. Mark it as a date table. So that was a slightly long tutorial, but and I select the trade dates. Yeah. Okay. So for you to do this, like the date shouldn't have gaps in between. It's not a proper calendar table. So because this is talking of trade dates, so you may want to also probably consider creating a proper calendar table, either with your DAX or with your Power Query, then connecting it to your model at the end of the day. So, but this is just like a simple demo of how to create relationships in Power BI, the whole concept of semantic models and all. I hope you enjoy this video and I'll love to see your work as well on this video. Thank you for staying tuned.